So when I came to US, I was very new to English as well as American English. I used to write words like COLOUR for color as compared to COLOR.
Is my voice Hello. Hello. I guess it's clear now. Yes. Am I clear? I guess audience, my voice is clear now. Welcome to Physics Cartoon Camera. This channel will gives you class recordings of class 9th standard to 12th standard, further graduations and post graduation courses, science facts, invited talks, jobs in physics, practical applications in physics, laboratory physics, hands-on experiments. So Physics Cartoon Camera, the main motto to reach rural India students. Yeah. Now continuation of conservation of momentum. Last class we have explained about force and laws of motion and gravitation, motion chapter. Furtherly we are studying today work, power, energy, the continuity of the last class, law of conservation of energy. So in this class, you will come to know what is conservation of energy and how mathematically we can able to do the numericals. So this is one thing. Shall we start? I guess audience are ready now. Enter the country, audience are ready now. Going to explore. Yes, is my voice is clear? I feel presentation also clear. All right. Now, continuation of the last class. What is law of conservation of energy? What is law of conservation of energy? This we will study today. A law of conservation of energy states that energy can be only converted from one form to another. It can neither be created nor be destroyed. So as you know that energy conservation, we can't create energy, we can't destroy energy, but we can change one form to another form. That is conservation of energy. Now here, yesterday we have studied two kinds of energies. One is kinetic energy, other one potential energy. Now, what is gravitational potential energy? What it refers? Let's say an object of mass m, we lifted height h. While we lifted height h, then what we noticed? Yes, it attains the potential energy. An object of mass m, we lifted height h. At the height h, it attains potential energy. So how to derive P is equal to mgh? We will see now. So whenever the mass m of an object, we lifted height h, okay, there is a work done. Work done is equal to force into displacement. Work done is equal to force into displacement. Force is equal to mass into acceleration into the displacement from down to top, that is height h. So acceleration due to gravity mgh, that is W. This work done in the form of potential energy. Therefore, potential energy is equal to mgh. Hope it's clear the derivation. Next. Now you can see in this picture, there is a simple pendulum which is oscillating. At the end points which is stopping, so it attains potential energy. At the center, at the down stage, which is oscillating more, which is having kinetic energy. You can see the graph over here. If the ball reaches to height at a certain height, that is gravitational potential energy, and the same ball come towards the downwards, then the kinetic energy will be more. So potential energy, kinetic energy, which is inversely proportional. Hope it's clear. Then coming to the second diagram, you can see that a mass m which is comes down at height h, you can see the blue line which is going top, and the red line is increasing while potential energy decreasing, which means kinetic energy, potential energy which is opposite. At height h, which is having more potential energy, while coming down, that is the mobile energy, we can call it as kinetic energy. So kinetic energy is increasing, potential energy is decreasing. Hope this picture is very clear to you. Now, under the free fall, an object which is under the free fall from point A, from the down surface at point A, that is height h, okay, that is height h. Now at the height h, which attains potential energy, while coming downwards, keep on, a ball is moving downwards. Now here what happens? Each and every point, both kinetic energy and potential energy must be same. Yes or no? That is law of conservation of energy. We need to prove it. Now coming here, at height h, at point A, a ball having its own potential energy, but there is no kinetic energy. So initial velocity u is equal to 0. initial velocity u value is 0 because at height h that position u value will be 0. Initial velocity. What about kinetic energy? Kinetic energy will be 0. But there will be a potential energy. PE is equal to mgh. Just now we have studied. An object of mass m which is lifted height h which attains potential energy. Now the total energy how much? Total energy is equal to both kinetic energy plus potential energy. Kinetic energy will be 0. Potential energy will be mgh. So total value will be mgh at point A. Now a ball which is coming to point B. At point B we need to identify both kinetic energy and potential energy and the summation of energy that must be equal to mgh. Let's see. At point B what is its kinetic energy and potential energy. Now ball comes to point B. So how much distance it is traveled? Let's say x distance it is traveled. From the ground, how much height is there? Remaining height h minus x. Okay. We will see. We will calculate. Now velocity at point B we will find out. Initially we can calculate kinetic energy. Then we will come to know what is potential energy over here. Now what is initial velocity of an object at point A? That will be 0. At point B we need to calculate velocity. Okay. So Newton's third equation will says that v square minus u square is equal to 2as. Yes or no? From here v square is equal to u square plus 2as. Okay. On the place of acceleration due to gravity, v square is equal to initial velocity u value will be 0. Clear? Now 2 into g s value x, that is v square value, we got it. We need kinetic energy. Kinetic energy Ke is equal to half mv square. Okay. Now that is equal to half into m into v square value. How much we got? 2gx. 2 will be cancelled. Finally mgx. So kinetic energy we got as mgx. Now we can calculate potential energy. Potential energy PE is equal to mgh. We know that. Now what is height h over here from the ground level? Which is h minus x, mg into the height h value h minus x. So kinetic energy K is equal to mgx. Potential energy P is equal to mg into h minus x. So what about total energy? Total energy is equal to both kinetic energy plus potential energy. So kinetic energy will be mgx. Potential energy will be mg of h minus x. Now what we will do? We will multiply over here. mgx plus mgh minus mgx. So mgx will be cancelled, which is equal to mgh. So the total energy is equal to mgh. Clear? At point A, again mgh. At point B, mgh. So now we are understanding, yes, conservation of energy matched. Now we will see at point C. In a free fall, an object at point C, what is the total energy? Both kinetic and potential energies. We can see at point C what happens. At point C, we can find out velocity. As you know that initial velocity u is equal to 0. We have to calculate final velocity at point C. Yes, as you know that v square minus u square is equal to 2as. In this equation, v square is equal to u square plus 2as. As you know, initial velocity will be 0. So V square is equal to 0 plus 2GH. Here height H at point C we are calculating from point A. So an object traveled at height H. Okay. Now that is V square value. What about kinetic energy? K is equal to half mv square. That is equal to half into m into v square value 2gh. 2 will be cancelled. Finally mgh, that is Ke value. What about potential energy? Potential energy at the down level will be 0. Now the total energy is equal to both kinetic energy plus potential energy. That is equal to mgh plus 0 is equal to mgh. That is total energy. So finally, energy, both kinetic and potential energies are same. Addition is same. Total energy will be same at point A, point B and point C. Clear? So conservation of energy applicable at free fall equation. Now there is a question. An object of mass 20 kilograms is dropped from a height 4 meters. Fill in the blanks in the following table by computing potential energy and kinetic energy in each case. Okay. Now, for simplifying the calculation, we can take the value of G 10 meters per second square. Now there are the options over here at height H 4 meter, 3 meter, 2 meter, just above the ground. What is potential energy and kinetic energy? As you know, potential energy PE is equal to mgh. So mass m value 200, g value 10 they have given, and height value we need to consider 4. So this is kinetic energy. Ke value we can find out here. Yeah. Now 4. So totally how much it will come? mgh. Sorry, it's not 200. It's a 20. Mass is 20. So 200 into 4, 800. 800 is the potential energy. So what about kinetic energy? K is equal to half mv square. Yes or no? So here velocity we don't know at 4 meters height. Okay. But which is the highest height? So kinetic energy will be 0. At 4 meters, which is the toppest, only potential energy is applicable. There is no kinetic energy. Kinetic energy will be 0. So what is total energy? That is 800. Clear? Now we can calculate the potential energy at 3 meters. So you can write it again 20 into 10 into 3. How much? 600. 600. Again the kinetic energy, how much it is? In that equation we got it. We can see. Kinetic energy K is equal to half mv square. K is equal to half m into v square. We need to find out velocity value. How to find out velocity? V square minus u square is equal to 2as. So as you know, initial velocity u value will be 0. So v square is equal to 2 into 10 into s value 3. How much? 60. So v square is equal to 60. We need to submit in kinetic energy. So half into mass m 20 into 60. Clear? Yes. Now v square value 2a. Now s value 3 we have mentioned. It's not 3. 4 meters to 3 meters, which is 1. Okay. So 20. This kind of mistakes we should not do. Then 20 we can do it over here. And 10 over here, that is 200. So kinetic energy will be 200. What about the total energy? 600 plus 200 is equal to 800. Clear? Now again the meter at 2 meters height. So PE is equal to mgh again. So 20 into 10 into h value at height of 2. How much it will comes? 400. Here this came as a potential energy 400. What about kinetic energy? K is equal to half into m into v square. Again v square value we can calculate. V square is equal to u square plus 2as. So 2 into g value 10 into s value 4 minus 2, which is 2. So which comes to 40. So 40 you can substitute here. So half into m value 20 into 40. So 400. So again 400 plus 400, 800. So total energy will be again remains the same. Clear? Next. So at the just above the ground. Just above the ground, there is no potential energy, maximum kinetic energy. That will be 0 and 800. Clear? So this is the way the total energy we are calculating from total kinetic energy plus potential energy. Next. What is power? Physicist having a lot of power. What is power? Power in the sense of work done in a unit time. How we can define that work done in a unit time in a simplest way? You can take two children, tell them to carry the weights. Let's say one student lifted up to 80 kilograms. Another student lifted up to 150 kilograms. Who is having power? 150 kilograms is having energy. But what is power? In a shortest time, how much work he did it, that's counted as a power. So W is equal to power P is equal to work done in a unit time is called as power. Power units watt. Clear? Next. Now total mechanical energy, what it is? Both kinetic energy and potential energy addition, we can call it as total mechanical energy. The power spent by a source is measured as the amount of work done per second, okay, by the source, or is equal to the rate of doing work per source. Power P is equal to work done in unit time. So power P is equal to W by T. Power depends on two factors, work and time. Now, work done by the both a person A and B is the same, but power spent by the person A is twice than the person B because person A does the work faster rate. So he taken in 5 minutes and person B taken in 10 minutes. So person A having power. So as a unit of power, watt. So power is equal to work done by time. So work done units, joules, time units, seconds. So joule per second is equal to 1 watt. So 1 watt is defined as the power spent on the doing a work of 1 joule in 1 second. Now 1 kilowatt, 10 cube watts. 1 megawatt, 10 power 6 watts. 1 gigawatt, 10 power 9 watts. Submultiple units of power are milliwatt and microwatt. Generally micro, there is a letter called as a mu. Okay. Now, there is a question for you. In CBSE, they'll ask this kind of questions. Clear? Now, I'm reading a question. Two girls, each of weight 400 newtons, climb up a rope through a height 8 meters. We name one of the girl A and the other B. Girl A takes 20 seconds while B takes 50 seconds to accomplish this task. What is the power expended by each girl? Repeating again. Two girls, each of weight 400 newtons coulomb, climb up a rope and height of 8 meters. We name one of the girls A and other B. Girl A takes 20 seconds while B takes 50 seconds to accomplish this task. What is the power expended by each girl? So they given 4 options. Generally students will be ask me the number of doubts. Sir, only in numericals we are facing problem. This is a common question from entire the country. And always I suggest read the question properly and write given data. What the given data in the question. So by this mean we can't get we no need to read again. So each weight W is equal to 400 newtons, okay, and the height 8 meters. Now girl A takes time 20 seconds and girl B takes time 50 seconds. So individually we need to calculate power. So power P is equal to work done by time. So power of a person we can calculate. So again work done in the sense of here work done. How to calculate work done? W is equal to force into distance. Yes or no? So force how much she applied? 400 newtons into S value 8 meters. Both also the same. But the time here 20 seconds. That is girl A. Now if you cancel it, 160 watts of the power, that is girl A. Now there are the two options of A and D, but we need to find out girl B power. Again force into distance by she takes 50, okay, so 64 watt. 8 into 8, 64 watts. So this is the way we can able to find out what is the power. So the right option is D. Okay. Yes. So this is the way we need to answer in examination. Always remember given data, required data. So what they're asking from us, that's fine. Now, so the right option is 160 watt, 64 watts. A boy of mass 50 kilograms runs up a staircase of 45 steps in 9 seconds. If the height of each step is 15 centimeters, find his power. Take G is equal to 10 meters per second square. This is the question. Now, what is given data? Given data is mass M is equal to 50 kilograms. How many steps he made it? That is distance. 45 steps. Each step how many centimeters? 15 centimeters. Okay. Now how much time taken? 9 seconds. Clear? Now G value will be 10 meters per second square. So what is power? Power P is equal to work done in unit time. Who is doing work? Boy is doing work. W is equal to again F into S, mgh. So these are all the formulas are there. So we can write mass into G into H in the sense of it's a distance what they have given, but time 9 seconds. So mass value substitute 50 kilograms into G 10 meters per second square into height H 45 into 15, which is in centimeters, we have to convert into meters. So 15 centimeters here right away you can convert into meters. So by 100 you will get that 0.15 meters into 45 steps. After multiplication of this, 45 into 0.15 by time will be 9 seconds. So finally, hope students can able to get calculate over here. So that is 375 watt. So power P is equal to 375 watts. Exactly, B option is correct. Next, power is the rate of doing work or it is the amount of energy consumed per unit time. Clear? Now commercial unit of energy. So the unit of joule is too small and hence is inconvenient to express large quantities of energy. We use a bigger use of energy called kilowatt hour. So 1 kilowatt hour is equal to 1 kilowatt into 1 hour. 1 kilowatt how many watts? 1000 watts into 3600 seconds. So finally 3.6 into 10 power 6 joules. Now next question. An electric bulb of 60 watt is used for 6 hours per day. Calculate the units of energy consumed in 1 day by the bulb. So how to answer this question? Before we discussed 1 kilowatt hour is equal to 3.6 into 10 power 6. Okay, we will see. You can see that power of electric bulb 60 watt convert into kilowatts. So 0.06 kilowatt hours. Time used 6 hours. So energy is equal to power into time. So 0.06 kilowatt hours into 6 hours. So 0.36 units. Hope it's clear. So 0.36 kilowatt hours. So there are the few questions the students can able to answer and send it to me. What is power? Define 1 watt of power. A lamp consumes 1000 joules of electrical energy in 10 seconds. What is its power? Define average power. So these are all the assignment questions for you. So finally, work, energy, power, we can summarize. What is work? Work in the sense of the product of force and displacement, call it as a work. Okay. Now next what we have studied, energy. What is energy? The capacity to do the work, call it as energy. Okay. Next, two types of energies. One is kinetic energy, other one is potential energy. So what kinetic energy we discussed? Kinetic energy in the sense of it's like a mobile energy. K is equal to half mv square and potential energy P is equal to mgh. How we defined kinetic energy? How we derived kinetic energy? An object of mass m, if you apply the F force, it moves with final velocity v, initial velocity u. Now we did work. W is equal to F into S. S means the distance. And as per Newton's second law, F is equal to m into A. So on the place of A, we substituted v square minus u square by 2s. So both s will be cancelled. So m into v square minus u square by 2. We multiplied with mass m, mv square minus mu square by 2. As initial velocity u is equal to 0, so k is equal to half mv square we have derived. Next, potential energy. What is potential energy? It's a storable energy. An object of mass m, we lifted height h. So while height h, we did something work. So W is equal to F into S. S means again height h. So F is equal to mass into acceleration into height h. Clear? Now mgh, on the place of A we substituted g, so m into g into h. That is potential energy. Next, what is conservation of energy? Conservation of energy, which says that energy we can't create and we can't destroy. We can alternate from one form to another form that we have discussed. So total kinetic energy and potential energy in a free fall object we derived. Finally, what is power? Power is equal to work done in a unit time. So later we have solved a few of the numericals according to CBSE. Now we will see what kind of questions are there it may ask according to CBSE. Yes, just a minute. Yes, there is a first question to all of you audience. Very interesting question. We can say this answer now. There is a question and answers time. Asima tried to push a heavy rock of 100 kilograms for 200 seconds but could not move it. Find the work done by Seema at the end of 200 seconds. So what is your answer? Generally children will start keep on working mathematically. Yeah, there is 100 and 200. But there is a logic over here. Seema tried to push a heavy rock. 200 seconds she pushed. But an object itself not moved. So as we studied that, work done is equal to force into displacement. Yes, Seema did the work. But is it displaced? Is it displaced? No. So once if displacement is 0, then work done will be 0. So this is the logic we need to apply. So W is equal to force into displacement. Since displacement is equal to 0, work done will be 0. Clear? So this is the way we need to write the answer. Next. At what speed a body of mass 1 kilogram will have a kinetic energy of 1 joule? Again, at what speed a body of mass 1 kilogram have a kinetic energy of 1 joule? So how to answer this? You can see what is given data. Mass m is equal to 1 kilogram. Kinetic energy is equal to 1 joule. What they're asking? What is required data? At what speed? V is equal to how much? As you know, kinetic energy is equal to half mv square. So kinetic energy they have given 1 joule is equal to half into 1 into v square. So v square is equal to 2. Yes, because 2 into 1, 2. So v square is equal to root 2 kilometer, v is equal to root 2 kilometers per second. Still some children they'll write 1.414 meters per second. Sorry, it's a meters per second. Yeah. Next question. Define 1 joule of work. Define 1 joule of work. This is one more question. So how to write this answer 1 joule of work? As you know that W is equal to force into distance. So work done units joules. So force units newtons. Distance units meters. So the question clearly define 1 joule of work. 1 joule of work we can define as 1 newton of force into 1 meter distance is called 1 joule of work. Next question. Next question. Identify the energy possessed by a rolling stone. Identify the energy possessed by a rolling stone. Yes, answer is very easy. I guess I'm expecting from the audience, students, uh, rolling stone which attains kinetic energy. Yes, a mobile object will be kinetic energy. Next. Next question. Identify the kind of energy possessed by a running athlete. Stone, athlete, all are the same answers. Running athlete also again kinetic energy. Okay. What would be the amount of work done or an object by a force if the displacement of an object is zero? You can see here work done is equal to force into displacement. Since displacement is equal to 0, work done also will be the 0. So they asked in another way. Next question. How much work is done by a weightlifter when he holds a weight of 80 kilograms on his shoulders for 2 minutes? Again, students will keep on work. 80 kilogram shoulder for 2 minutes, they hold it. But this worker not moved at all. So once displacement is 0, then work done will be 0. Now, there is the next question. A car and a truck are moving with the same velocity of 60 km per hour. Which one has the more kinetic energy? Mass of a truck is greater than mass of a car. So as you know that both are moving with the same velocity. So velocity v is equal to 60 km per hour. So which kinetic energy is very more? Ke is equal to half mv square. So the mass of a truck is greater than the mass of a car. Since kinetic energy of a truck is greater than kinetic energy of car. So truck kinetic energy is greater value. Next question. A body is thrown vertically upwards. Its velocity goes on decreasing. Write the change in kinetic energy when its velocity becomes 0. Repeating again. A body is thrown vertically upwards. Once vertically upwards, what happened? At the height h, final velocity will be 0. So write the change in the kinetic energy when the velocity becomes 0. So this is the question. Answer here, as you know that Ke is equal to half mv square. At the height h, velocity will be 0. Then what change in the kinetic energy? Kinetic energy will convert into potential energy. Fine. Once the final velocity is 0, yes, it stopped. At height h, a body having potential energy. That is the answer. Next question. A force of 10 newtons moves a body with a constant speed of 2 meters per second. Calculate the power of the body. So this question how to answer? You can see the force of 10 newtons. F is equal to